everyone, my name is Pritam and welcome to another video of the data structure playlist. In the playlist, we are already discussed about various topics on trees. Okay, so this is another kind of tree which I want to talk about today, which is called heap. Okay, it is very much essential and important in nowadays software development, or I would say data engineering. So heap is one of the very much important and prestigious data structure which actually got used widely in various kinds of algorithms. Okay, so what exactly heap is? In simple word, heap is nothing but one kind of binary tree. Okay, one kind of binary tree it is. Okay, now for what is the difference between the binary tree and a heap? Okay, obviously binary tree has to satisfy some of the characteristics by which we can tell that okay, these are actually tree heaps, not only binary tree. Okay, now what are these conditions? Number one is obviously structural property. Structural property. Another one is what? Another one is heap order property. Okay, I would say you could increase the 1.25x speed in your YouTube player, okay, for having a better experience, as I am talking very slowly. So I would say I think it would be, or 1.35 would be a better one. Okay, you can try with that. Okay, so now what is structural property is? Okay, so obviously structural property means two things: all the levels have maximum number of nodes. Okay, obviously these are the things interviewer will ask you if you are a fresher, okay, or an experienced developer also. They may ask, okay, all the levels will have max number of nodes except the last level. Okay, another one is, okay, in the last level all the nodes occur from left to right. Okay, left to right, it should be sorted. Okay, in the last level all the nodes occur to left. Okay, and what is heap order property? It is nothing but, okay, heap order property is nothing but the key value. Okay, the key value, okay, in any node n, for example, is either greater or smaller than, okay, smaller than or equal to the key values in both its children. Okay, okay, so let me explain what exactly these things are. Now let's talk about the structural property. Okay, what's it here? Like for example, if this is a binary tree, okay, so here in the last level, for example, okay, in the last level what you said that like in the except the last level all the levels should be maximum. So this is maximum, this is maximum, this is maximum, except the last level every level is maximum. So this is one condition, it's passed. In the last level all the nodes occur to the left. Now if you see from left to right, any one, like any place is empty? No. For example, if you have this one, but for example you don't have this one, then it is not going to work. Got it? Okay, so obviously there should be another one here. Okay, now if you have another node here, and for example this node you don't have, then also it's okay. Like, the point is, from left to right, no place should be empty in the last level. That is the main thing. Okay, and for example, okay, except the last one doesn't mean that like it also cannot be full. It can be full, it can be in the maximum one, so that's not a problem. Okay, so that is the point of heap, structural property. Okay, now let's talk about the heap order property. Now heap are actually of two types. Actually heap are of two types. First one is max heap, another one is mean heap. Now what is max heap, what is mean heap? Max in the heap order property, if you could see here, I have already mentioned greater than or smaller than equal to. Now what is the point? Okay, normally equal to, we normally don't care about this equal to part, because normally we don't put duplicate data in heap. Okay, but by chance if it comes, then okay, it can be taken care of. Okay, so for example, yeah, for example it could be 100. Let's talk about max heap first. Max heap में क्या होता है, like parent should be greater than the children. Okay, parent should be greater than children. Now which one would be greater, this one or this one? It doesn't matter, it has to be greater than both the one, and any one of them would be greater than any of, like left could be greater than right, or right could be greater than left. That's not a problem. The main thing is the root or the parent should be greater than the children. Now here for example it could be like a 70 60, it could be 50 30. Okay, like that. So this is the thing. Okay, so this is called max heap. Okay, let me give a generalized formula. Okay, for max heap. Okay, so A, B and C. So here A greater than B and A greater than C, both the conditions should be verified. Whereas in mean heap, what will happen? In mean heap, if I say A, B and C, obviously A less than B and A less than C. These are the two conditions to be followed. Okay, so this is the difference. This is the difference actually. Okay, which you need to understand. Okay, I think you are getting it. So when both the properties are satisfying by any binary tree, then only we are going to call them as a heap. Got it? Now let's talk about something more about the heap. Okay, now what is the, like, from the structural property we can see that a heap is a complete binary tree, and obviously its height is log of n plus 1 base 2. Obviously, right? Log of n plus 1 base 2 according to the formula of the binary tree. Correct? From the heap order property, okay, we can say that like the key value in any node n is greater than or equal to the key value in each successor of node n. Obviously this thing I have already explained. Correct? Now this means that the root will be the highest key here. In terms of the max heap, what will happen? This max heap root will be the highest value. Root is the highest value node, whereas in mean heap root is the lowest value node. Okay, that's clear, right? Yeah. Okay, so in the second property we can change greater or smaller, obviously based on the max heap and mean heap. Okay, if it is greater than, then obviously it is a max heap. If it is smaller than, then obviously it is a mean heap. Correct? Now let's take some example of max heap, and let's take some example of mean heap. Okay, what are max heaps? Okay, so let's take some example. Okay, they are like 45. Okay, then 35, 12, 13, 25 and 8. This is the example number 1. example number 2, for example 56, then 43, then 55, then 9, then 5, then 18, then 4. Now example number 3, okay, for this one, okay, let's draw it here. Okay, example number 3, what will it happen? Like 90, okay, then obviously it is coming as 70, it is coming as 80, it is coming as 12, it is coming as 45, it's coming as 24, it is coming 59. Okay, now it will be 14, 10, 38, 46, 32, 37. Cool. Now if you see all these 3 examples, these are the examples of max if. So how we will identify? First of all the levels are having high maximum nodes except the last one, and then the last one left to right is there. It is possible. In case of here also same, it is there. All the levels are full already. Here also all the levels are completed except the last one, and last one is like left to right, it is already packed up, so it is fine. Now let's check the heap order property. It is greater than these two, yes. It is greater than these two, yes. It is greater than this, yes. It is greater than these two, yes. It is greater than these two, yes. It is greater than these two, yes. Similarly here also, it is greater than, it is greater than, it is greater than, this is also greater than, this is also greater than, this is also greater than, this doesn't have any children, these are all fine. So yeah, we all can see that these are the max heap. Okay, for example, in any of them, it could be like, for example 70. Okay, it could be like 70, then it is not going to be the max heap because of this property is not satisfying. But as it is 18, it is satisfying. Okay, the nodes in a heap are actually partially ordered. Okay, that is, there is no ordering of left and right child. Any of the 2 children can be greater than each other. So heap is not a search tree. Let me tell you that heap is not a search tree. Heap is not a search tree at all. For searching we use BST or binary search tree, if I'm not wrong. Okay, correct, we already have talked about it. Yeah? So yeah, that is fine. Now let's forward. Okay, now what else more are remaining? Okay, heap can be used in the problems where like the largest element or the smallest element to be determined very quickly. For example, if you want to find the largest element from this tree, what will you do? It will take O of 1 time complexity to get the root value. Okay, we will talk about it how heap internally actually implemented. We will be using array method and linked list method, and for both of them we will get to know when we will be writing the codes. Okay, and the largest of the smallest value can also be determined by sorting the data in descending or ascending order and by picking up the first element. That is fine. Okay, but in that case we have to do more work than required, because we just need to find the largest or smallest element, and for that we have to keep all the elements in order. So that is the challenge actually. Okay, so from now onwards we are going to talk about only max heap. We are not considering any mean heap. Okay, mean heap and max heap both are same, just greater than or smaller. That's the main difference. Okay, heap is a complete binary tree, and we all know that sequential representation, okay, is efficient for this type of trees. So heap are implemented using arrays. Obviously heap will be implemented in arrays, but also like using linked list also we can implement heap. Okay, so which one to use, that depends on the business model, that depends on the business logic, that depends on the company to company, architecture to architecture, it differs. But normally we take arrays for the simplicity. Okay, So another advantage in sequential representation is that we can easily move up and down the tree. Okay, while linked list representation, it won't be possible. So directly we cannot go back to anyone. Like if we are having arrays, okay, we can directly access any element. Okay, but in case of linked list, we cannot do that. Correct? Like the architecture, like it will be implemented like this, and like there will be a lot of drills. Like you need to some threads to go back to the root and all. So threaded binary tree concept will be coming up. So it's going to be a little bit hectic. That's why normally we don't use it, but still I will show you how actually it will be implemented. It's like more likely on like tree only. Okay, so you do not need to worry about that. Okay, if like normally now what will happen. Okay, let me take this one as example and let me draw the like array. Okay, so how many elements are there? Obviously 1 2 3 4. So maximum how many elements we can have? Obviously 2 to the power, how many? 2 to the power, let me know in the comment section, by the way. Okay, so it will be like obviously 2 to the power 4 minus 1, that means 15. Correct? Okay, so like and index will be maximum 15. So 0 to 15 we can say, or 1 to 15 also we can say. So yeah, let's draw the array here. Okay, so what will happen, like it will be coming as, well, for example, let me take it from 1. Okay, so obviously this will be 1 2 3 4 5 6 7 8 9 10 11 12 and 13, and it will be 14 and 15. Okay, so these two will be empty obviously. So how will you implement? Like 90 78, sorry, let's start from 1. Okay, you can start from 0 also, but I am starting from 1. That's not a big deal. Okay, so that is how it will be implemented. Okay, now the question comes that like if I'm starting the index from 1, okay, so what will happen? Obviously the first node, okay, if the parent is I, okay, the next node will be obviously 205, and the rightmost will be 205 plus 1. Correct? If you see here 90, the next one is 205, that means 2, and 205 plus 1, it's 80. For this one 24 is 2 into 2, and 59 is 2 into 2 plus 1. So that is how actually it will be the left one, it will be the right one. Let me write that. It will be left and it will be right. Cool. Now that is how the array representation works. Okay, and we will talk about it, don't worry, and the code also we will talk about it, how will you do that. Okay, so this is the way. And in terms of linked list representation, let me take a smaller one, and let me show you how linked list representation will be there. Okay, it will be same by binary search, binary tree, so nothing new. Okay, so that is how the linked list will be implemented, and another node will be there which is called the root node, that will point here, and it will have the address, for example 100. So that is how by the root one we will like call it, and we will go here and there and here and there. Okay, and that is how we will iterate. Okay, but this is going to be a little bit complex. The easier one is the array one, and we will be using this one only to implement, okay, the heap using our raw code without any library, by the way. So yeah, that is all about heap as of now. I have given you a lot of ideas about heap, what exactly heap is, and how like you should like implement and all. Okay, so this is the thing. In the next video we will talk about insertion in heap. Okay, and also the deletion operations we will talk about, and after that we will go to the code and we will write the codes for all the operations in C. And also we will go through the building a heap. Okay, build heap method also we will talk about, don't worry. And yeah, that is all about heap as of now. Okay, and by the way, another thing, the heap actually data structure is actually implemented mostly in three mostly used part. Okay, first one is selection sort. Okay, another one is implementation of priority queue. another one is heap sort, the most important one, heap sort. So these are the applications of heap, mostly used applications. Okay, applications of heap, mostly used. Okay, apart from that also we normally do use, like if you find the kth largest element in the array or k smallest element in the array, you should have to use the heap. Okay, there are other methods, but heap is also a very good option to do. Okay, so in the next video we'll talk about the insertion in heap, and till then keep learning and keep exploring, and thank you so much for watching the video. Please hit the subscribe button if you're new in the channel, and like the video if you really like the content which I'm putting into the thing here. Okay, so yeah, and yeah, thank you so much guys, and see you in the next video.